So I'll be talking about 400ZR today. So cloud service providers continue to innovate to provide more cost-efficient and reliable service to their customers. With the increased requirement for the low latency applications and local data processing, a more distributed data center architecture really becomes essential. And an extension of what previously was dominated by mega data centers. So naturally, this increases the demand for data center interconnect bandwidth. Therefore, you need a much more cost and power effective solution than traditional optical transport equipment and you previously had available. So this is where 400ZR comes into play. Inphi had introduced the 100 gig switch pluggable COLORZ DWDM transceiver in 2016 and then worked with industry partners in the OIF to standardize the 400 gig coherent version. So this was an industry-wide effort, and the goal was to integrate a standardized coherent transceiver into the power envelope and the size of a 400 gig short reach module. So this allows switch and router companies to offer the same density for both coherent DWDM and client optics in the same chassis. Andy mentioned that in his presentation. This is really something brand new and something that changes the industry. So this eliminates an entire layer of the network connectivity by connecting the DWDM directly from the data center switches. So 400 gig ZR QSFP-DDs or OSFPs enable large cloud operators to connect metro data centers up to 120 kilometers at a fraction of the cost of traditional coherent transport systems. So here you can see the basic 400ZR concept. At the bottom is the use case drawing from the OIF implementation agreement, switch-to-switch connection via an optical line system, and 120 kilometers or 80 kilometers of fiber, depending on your implementation. This is defined with a minimum of minus 10 dBm output power on the transmitter and 26 dB OSNR performance. People wanted to make sure silicon photonics implementations are enabled. The block diagram shows you the components. I'm listing some of the major goals of the standards as well. So at the core, you have a low power 7 nanometer coherent DSP. We spent a lot of time and effort as an industry to define interoperable optics specs here. Including the framing and the forward error correction. We chose the CFEC here. In addition, modules include an industry standard firmware management interface that enables full performance monitoring directly from the module via the switch. So you don't need any more custom vendor dependent monitoring software. So at the end of last year, Inphi then announced COLORZ 2, which was the industry's first 400ZR QSFP-DD coherent transceiver. And obviously COLORZ 2 follows the OIF 400ZR standard. And we already announced successful interoperability testing with several vendors over 120 kilometers. We also announced a trial with Verizon Media using Arista switches. So this is reality. Besides meeting the OIF specs, there are several industry firsts that we had announced. At the core is our low power 7 nanometer coherent DSP called Canopus. This enables 400ZR as well as, Andy also mentioned that earlier, extended reach ZR plus modes, 400 gig up to 400 kilometer in a QSFP-DD form factor still. The silicon photonics integrated circuit includes all the transmit and receive functions in one chip And of course, we also use our internally developed low power TIAs and drivers. Given our experience in shipment history with our first generation COLORZ 100 gig product, we have a lot of know-how on ramping these small form factor silicon photonics based DWDM transceivers. So here you can see a typical 400ZR test setup. We have a polarization scrambled input signal, and we show the OSNR penalty here for 80 kilometer as an example here, very minimal as you can see. We have the spectrum shown on the bottom left of all the channels. And you can see this 1RU switch with 32 QSFP-DD 400ZR modules in 1RU, which again is really phenomenal to have that much DWDM bandwidth in one switch. So these innovations here in COLORZ 2 enable new operational models for end users, saving both CapEx upfront and OpEx via hardware, software, space, and power savings. So the operators can therefore place more revenue generating servers into the limited space and power budget that they have in their data centers. On this slide, to summarize, again, 400ZR allows you to get up to 14.4 T per 1RU if you max out the capacity, and up to 25.6 T per fiber at a fraction of the cost and power of any traditional DCI system. And then if you go with the 400ZR Plus version, you can go up to 400 kilometer at 400 gigs, still in a QSFP-DD form factor. What's next? Again, this IP over DWDM trend, I believe, will continue beyond 400ZR. We started at 100 gig with the introduction of COLORZ over 4 years ago. Now, this year, 400ZR and 400ZR Plus come into play. And then we just kicked off the 800ZR project in the OIF. And that will continue to increase the flexibility and the density of these form factors for many years to come in the future.
Hey, thank you, Joseph. I am just looking at the questions here. There's a couple of questions come in. One question here is there also an OSFP-FF question?
Yes, so the 400ZR form standard is agnostic. The intention for it was obviously to go into the smallest form factors. So both QSFP-DD and OSFP are options for implementations in the market.
That's cool. Now I know 400ZR has gone to long distance. I mean, what comes next? I mean, if you wanted to look out the next few years, I mean, what do you think is going to be the next phase beyond 400ZR?
So, I mean, obviously the cloud operators are first to embrace 400ZR. Microsoft and Google publicly supported the standardization effort in the OIF, but others are embracing it as well, other cloud operators. And I believe right after that, smaller cloud operators as well as carriers will implement 400ZR and 400ZR Plus. They'll realize they can take advantage of the scale, the interoperability, and of course the power and cost savings that the cloud operators help them to achieve.
Great.
as I mentioned on my last slide, 800ZR will double again the bandwidth per lambda, and you'll be able to go at even. Sorry, I'm sharing the wrong thing here. You'll be able to double the speed once again.
Okay, so I have a question here. I'm not sure if you can answer it, but if you can give us some idea, that would be good. A couple of folks want to know what the approximate price range for 400ZR Plus would be. I mean, clearly you're not going to give detailed prices, but can you give us some ideas at all?
Good question. I don't know if we're publicly talking about pricing in this forum, but obviously it will be well below what current systems are, and even next generation integrated systems are.
No, that's okay. I fully expect that type of answer. I got another question that just come in, and I don't expect any detailed answers, but what is roughly the price ratio between the ZR and the ZR Plus? That's probably a little easier to answer, perhaps.
Yeah. I mean, you'll have slightly modified test and for the module itself, as well as a slightly different module potentially, depending on the vendor. I would expect the delta to be more than a few percent and much less than 50%.
All right, that's a good idea. So it gives us something at least good to work with. I hope that question came from Frank and a couple others, so I hope they're happy with that. And I think, let me look at the time here, we're 8:57 in California. I think I'm going to thank you for your great talk, Josef.